Good morning, everybody. This is a live severe weather briefing as we have a lot to talk about with a massive pattern shift that is imminent across the eastern U.S. here. We have a southern stream storm system that's coming in along the southern U.S. That brought a couple of tornado warnings yesterday across southwestern Louisiana, a couple of supercells near the Houston area as well, including an early one that crossed Galveston Bay. And that same system is going to phase with the northern stream system. This is a pretty textbook phasing of the northern and southern stream storm systems combining into one massive pattern shift. And while that happens, it does look like there's a chance, a legitimate chance of some fast-moving tornadoes during the day on Monday. Maybe a couple of different waves of those tornadoes as well. And that cutoff system that I mentioned across the southern stream that's moving across Dixie Alley. This weekend. It's west of there now, but then tomorrow it ejects across Dixie Alley. This is actually that cutoff system, and once the northern stream system phases with that cutoff, this basically lifts rapidly on the east side of the new parent trough. And this is the 850 millibar map here. And this surge of 850 millibar winds out of the south, that's going to be impacting portions of the mid-Atlantic, potentially New York City during the day on Monday. This is actually that southern stream cutoff system that phases with the northern stream trough coming in from the northwest. And then it looks like in its wake, an elevated mix layer, or basically a dry slot at the mid-levels, overspreads a plume of moisture with mid-60s dew points, even some upper 60s dew points down into eastern North Carolina here. And when that elevated mix layer in the wake of this cutoff system moves in across a warm sector with that plume of moisture, that's going to increase instability across eastern North Carolina, maybe as far northeast of the southern Delmarva Peninsula as well. Coastal Virginia could definitely see a threat of fast-moving tornadoes as well from this. But in the wake of this cutoff system here, we still have 50 to 60 knot southwesterly low-level winds, about a kilometer above the ground. And that's what all this massive red color is, all the way down into coastal South Carolina. And that low-level jet in its wake, that's going to be responsible for substantial low-level shear. In the wake of this southern stream system here, that's going to be ejecting toward North Carolina. The dry air coming in at the mid-levels that I'll show you on the forecast soundings comes in the wake of that cutoff system, and that's going to create enough surface-based instability and breaks in the clouds, along with that very strong low-level wind shear to develop a threat of those tornadoes in eastern North Carolina. And then in its wake, several inches of snow is going to fall down the spine of the Appalachians. That'll be West Virginia, down there to the Smoky Mountains. That border between Tennessee and North Carolina could easily see 5 to 8 inches of snow. Big-time northwesterly winds. That snow is going to fall in the form of convective snow squalls, too. They're going to be moving over the spine of the Appalachians. So I'm going to be likely chasing this tornado threat in eastern North Carolina on Monday, and then we'll double back and then cover the big-time snow in the Appalachian Mountains before returning back home here at my mom's house in upstate North Carolina. But definitely a pretty legitimate shot at tornadoes. Here is a NAM forecast photograph for eastern North Carolina, 18Z on Monday, which is about 1 p.m. Eastern Standard Time. And here you can see those very fast storm motions of about 50 knots out of the due northeast. And there is going to be some pretty shallow critical angles, a textbook North Carolina forecast sounding here with the low-level jet or very strong 1 to 2 kilometer winds compensating for these shallow critical angles that are going to be about 45 degrees there. You normally want something a little closer to 90 degrees to maximize that tornado threat, to have maximal streamwise vorticity intake, but you can have these shallow critical angles in the eastern U.S., including the Carolina, Piedmont, eastern North Carolina, these types of systems with these big-time easterly troughs, so that axis of the low-level jet hanging on right there, coastal Carolina, Virginia, up through Delmarva. And if this low-level jet can back even just a little bit more with that parent trough digging a bit behind that leave cutoff system, then we're going to have a hodograph that's even more curved. And this is already indicating a PDS tornado as a possible hazard type based on historical soundings there, even with this relatively shallow low-level jet. But some of the other models, the HRRR is showing a more backed low-level jet, still just as strong, but that would really ramp up that storm relative helicity in the lowest kilometer and 3 kilometers with this hodograph. but very strong wind fields expected. So even with this relatively shallow critical angle, I am anticipating this strong low-level jet, the 1 to 3 kilometer winds, to really elongate that hodograph to help compensate for that shallow critical angle. There's very long shear vectors here. You can see the surface winds are forecast to be due southerly at about 10 knots. That's a pretty weak surface wind. And normally, many chasers think that if you have a weak surface wind like that, that's going to be a reduction of the tornado threat. But it's actually quite the opposite, especially in the eastern U.S., because when you have this decoupled atmosphere with a relatively weak surface wind, and then you have a south-southwest wind at 50 knots over top of that, that creates a lot of speed shear. So with a 10-knot surface wind and about a 50-knot wind just above it, some directional shear, that creates 40 knots of 0 to 1 kilometer shear, which is more than substantial for even a strong tornado threat. And that's what's being indicated by these forecast photographs by the NAM. The NAM previously, yesterday and earlier runs, was actually showing pretty weak instability across North Carolina. But now the last few runs, the 6Z and the 12Z NAM, are starting to pick up on that very strong elevated mix layer, that dry slot coming in the mid-levels of the atmosphere, and creating just enough instability, surface-based instability with those mid-60s dew points to realize a fast-moving supercell and tornado threat. And look at this hodograph. Definitely not very much in the way of veer-back veer with this hodograph. As often in the eastern U.S., you get a little bit of a reduction of those veer-back veer type profiles that you often see. And really the low-level winds here dominating with a big curved hodograph like that. A little bit of veer-back veer, and then some strong upper-level winds in the warm sector of this phasing system. And my plan is to also go over the long range. We've got a double-barrel pattern shift, as I'm going to call it. This is the system right now. As these two systems phase and this system becomes vertically stacked over the northeastern U.S., the long-range forecast is showing yet another monster upper-level storm system to come in on the backside. A lot of flow here on the backside of this trough. This is going to reinvigorate this eastern U.S. trough and really continue the cold temperatures with waves of precipitation across the eastern U.S. and especially the southeast as we're going through early December. And it might be the middle of December before we get another pattern shift and the return of these warm temperatures and a subtropical ridge across the southeastern U.S. Looks like we're definitely trending toward this classic ridge trough pattern across North America, with a monster ridge dominating the western U.S. and a trough in the eastern U.S. That's not a favorable pattern for big snow for the Rockies, but it is a favorable pattern for snow across the northeastern U.S. Plenty of ski resorts up there in the northern Appalachians as well definitely are going to benefit from this pattern. And this is also a pretty textbook nor'easter pattern as well. Someone's going to get slammed by this pattern with big snow. This initial phased system between the northern and southern streams looks like it's going to dump a swath of snow from Indiana across Ohio, western Pennsylvania, with really the heaviest snowfall totals in the lake enhancement zones of northeastern Colorado, northwestern Pennsylvania, and more of a pure lake effect, lake enhanced event into western New York on the plateau and the higher terrain out there in the favored northerly and northwesterly flow snow belts up there. Some lake enhanced, classic lake enhanced pattern. Some Cleveland's likely going to get hammered from this. Portions of southern Ontario are going to get hammered as well from this lake enhanced lake effect event, with the added lift from this trough and lobes of vorticity rotating around it, helping to ramp up that lake effect threat. And we're just going to have to monitor this, but the long range eastern U.S. looks to be quite cool as we have these incredible double-barreled upper-level storm systems, the eastern, most of which is the one that we're going to be watching for early next week. And I'm going to now chart the phasing process between these two systems. We're going to use the NAM model to look at this classic phasing between northern and southern stream storm systems. There you can see that cutoff system here in the NAM. This is 12Z Saturday. This is basically right now, Saturday morning. You've got this cutoff system in the southern stream. You have the subtropical jet, which usually is located a little higher up in the atmosphere than your classic polar front jet stream. If you go up to 300 kilometers, a little higher in the atmosphere, You can see some stronger flow associated with that subtropical jet, and that's because the subtropical jet exists a little higher up in the troposphere, up around 200-300 millibars, whereas the core of the polar front jet extends lower in the troposphere into the middle levels of the troposphere down toward 500 millibars. So there you can see this dual jet structure. You've got the polar front jet stream to the north, you've got the subtropical jet stream to the south, you've got this cutoff system that's in the southern stream, and eventually they phase in the eastern U.S. Here you can see this system coming in from Alberta, basically an Alberta clipper. This is the northern branch system that's going to help phase with this southern stream, forecasting out about 6 hours. You can see the cutoff starting to eject across the southern plains. And here you can see the trough axis for the northern stream system and the associated jet streak with that northern branch system really starting to ramp up and intensify. There you can see that trough axis has a strong positive tilt as it's ejecting from Canada. Definitely a textbook cutoff system ejecting over the southern plains by Saturday evening. It's going to be directly over Amarillo by about 7 to 10 p.m. tonight. Cold pocket of air aloft that could be associated with some snowfall, maybe some frozen precipitation with such a cold pocket of air aloft. And there you can see that little bowling ball associated with the cutoff system. 500 millibar temps, minus 27 degrees C down there over Amarillo tonight. Sometimes these bowling ball like systems can produce some surprise snow events across the southern high plains, including Amarillo. I'm not seeing a lot in the way of precipitation, but it does look like there could be some frozen precipitation beneath that bowling ball of an upper level system tonight in the Texas Panhandle. Maybe a little bit of panhandle magic down there. But there you can see that southern stream system. The subtropical jet located to its south is helping to proliferate this upper level system through shear vorticity. So you have a strong subtropical jet, you've got a cutoff system, and this subtropical jet along the southern side is causing this upper level system to sustain itself, if not even intensify a bit as it moves across the southern U.S. And when you have this strong flow on the southern side, you get the generation of cyclonic shear vorticity along the southern edge, the base of this trough, and that causes even a cutoff system like this to deepen as it's moving across the southern U.S. Ahead of this northern stream trough that is diving south out of Canada into the Dakotas, the northern high plains. Classic phasing of these upper level systems. This is on Sunday morning, and there is a marginal risk for severe weather across Dixie Alley out ahead of this system all the way through the Carolina Piedmont for late Sunday night. But there is going to be a cold wedge of air that forms to the east of the Appalachians. And as this system arrives, that strong low-level jet ahead of the cutoff system, that initial pop that we saw in that low-level jet, that's going to help to erode the wedge of cold air banked up against the east of the Appalachians. And then by Monday, late morning, that threat of severe weather definitely arrives for eastern North Carolina, southeastern Virginia, up through the Delmarva Peninsula. But here you can see that phasing of these upper-level storm systems happening here. Basically an Alberta Clipper-like system coming in from the south through the Dakotas by Sunday, midday, diving south through the Dakotas into the upper Great Lakes. A lot of flow still on the backside of this northern branch system. It is a bit east side loaded, but the phasing of these northern and southern stream systems in the eastern U.S. is going to initiate this pattern shift that's going to continue through the early part of December. So here is this trough axis, and eventually this system is going to become dominant, and then this cutoff system basically lifts up on its eastern periphery, basically as a little bit of a pop in the low-level jet. And then in the wake of this system, once the phasing is complete, an elevated mix layer is going to advect in from the west, and that's going to advect in over top the moisture axis in eastern North Carolina, even eastern South Carolina, southeastern Virginia, into the Delmarva, and that's really going to ramp up that instability during the day on Monday, allow for breaks in the clouds to lead to surface heating, and then a strong low-level jet in its wake is going to happen. So look at this cutoff system starting to lift to the northeast ahead of this trough. This trough now has a majority of the flow located on its backside. So the northern stream trough is definitely in an intensification trend, even though it has a positive tilt to the trough axis. It's definitely intensifying. It's got a lot of flow on the backside of it. Eventually, it's going to gain a neutral tilt and then a negative tilt, and this cutoff system is going to lift on its eastern flank. Could even lead to a period of severe weather Monday morning. So this is Monday morning, middle of the night, Monday, early morning hours on Monday. That cutoff system arrives to the southern Appalachians. There is going to be a wedge of cold air that's banked up against the Appalachians, and I can show you that here in the NAM. Just a little bit of a wedge of cooler air that's going to dive south ahead of the southern Appalachians. But really, it's this lead cutoff system that ejects northeast through the mid-Atlantic, and then in its wake, you're going to have this dry air coming in the mid-levels of the atmosphere, and we're going to track that elevated mixed layer and discuss its role in the severe weather on Monday. But on Monday morning, the lead cutoff system, which is starting to weaken and lift northeast, really reinforcing the warm sector of this new parent trough as we're starting to get perfect phasing between these two systems. But it is possible that there could be Monday morning severe weather in coastal North Carolina with this lead system, as there is going to be a pop in the low-level jet ahead of this system. There you can see that low-level jet starting to increase, and even a little bit of a mini coastal system here with a pop of a low-level jet there in eastern North Carolina. That's from the pressure falls of this arriving upper-level system. That initial low-level jet pop associated lifts up toward North Carolina, and then ahead of that cutoff system, you get a ramping up of that low-level jet out of the southwest, and that's going to happen behind this lead pop in the low-level jet, and that's going to be associated with an elevated mix layer as well. The 6Z NAM actually had this cutoff system lifting well to the northeast toward New York City, and then just this parent trough gaining a neutral tilt, eventually a negative tilt, and then a reinvigoration of that low-level jet behind it. Now, though, in the 12Z NAM, it seems like this lead, the southern stream cutoff system, is a little bit slower, less progressive, but there is a lead system, a lead pop in the low-level jet that lifts up to the north through the mid-Atlantic toward New York City by late morning on Monday, and then an increase in the low-level jet associated with the arrival of that elevated mix layer and some destabilization as well. Let me see if I can show you that elevated mix layer here. So here you can see that elevated mix layer arriving. This is at the lead cutoff system lifting northeast through the mid-Atlantic. And when this dry air comes in at the mid-levels and surges into eastern North Carolina, eventually southeastern Virginia, and eventually arriving in the Delmarva Peninsula by early afternoon, that's going to allow destabilization to build across eastern North Carolina, southeastern Virginia, even the southern Delmarva. So you can certainly see this elevated mix layer, classic elevated mix layer here in eastern North Carolina on Monday. You could definitely see that in the forecast sounding as well, the NAM forecast sounding. This green line is the moisture profile. And that is that elevated mix layer at 500 millibars. And that's really the reason why this severe weather event is probably going to go big, with an arc of supercells developing over the Carolina Piedmont, surging east across eastern North Carolina. Some possible renegade clusters of supercells as well, starting as early as Monday morning across coastal North Carolina. But this elevated mix layer here is going to allow cloud breaks to happen. It's going to allow these low-level lapse rates to steepen. Temperatures in the 70s, dew points in the mid-60s here. A lot of speed shear in the lower levels of the atmosphere. And a photograph that looks a little bit shallow, but with such strong 1, 2, and 3 kilometer winds up there, probably those low-level kinematics are going to be enough to compensate for those shallow critical angles. And that elevated mix layer coming in over top, the moisture at the surface should create a very unstable environment, steep lapse rates at the low levels. And there you can see that elevated mix layer. Anytime you bring these stout elevated mix layers that are normally a characteristic of the Great Plains, anytime you bring these to the east, bringing characteristics of the west to the east relative to severe weather, that's when you get these big time severe weather events. And in this case, it's due to the phasing of the southern stream and northern stream systems there, the arrival of that elevated mix layer. There is going to be some CAPE as well. Obviously, because of that elevated mix layer coming in, CAPE's of 1,500 to 2,000. CAPE's as high as 2,000 possibly for the Outer Banks of North Carolina as early as late morning on Monday. could certainly set the stage for some renegade supercells. And these Monday morning photographs out in the North Carolina Outer Banks, out in coastal North Carolina, have more favorable critical angles too, a little bit closer to 90 degrees. So those photographs are going to be even more favorable in eastern North Carolina. But then the arrival of stronger low-level kinematics, that low-level jet accelerates above 50 knots. And so even though the critical angles are a little bit more shallow for that second wave, there still is a chance for multiple rounds of severe weather with tornado potential across eastern North Carolina per the latest NAM. And we're going to look at the HRRR as well and see exactly what it shows for convective evolution. But it does look like that instability, surface-based instability, could reach up easily as far north as Delmarva by at least about 21Z as we get further into the afternoon. Definitely looks like instability dominating the entire Delmarva Peninsula there by Monday afternoon. And that low-level jet hanging on in eastern North Carolina to create round after round of severe weather, and then eventually this arc of supercells arriving in the North Carolina Outer Banks. Probably going to be some supercell waterspouts out there in Cape Hatteras, maybe even a couple of rounds of supercell waterspouts. And here you can see later on the critical angles begin to get more shallow as we go through the day in eastern North Carolina. But we do have an increase in those 1 to 2 kilometer winds to above 50 knots happening there, which should help to sustain that tornado threat in eastern North Carolina. And then as we go through Monday evening, that instability shear axis finally starts to shift off the North Carolina Outer Banks there. Well, let's look at the HRRR model, the convective allowing model here. See if it doesn't quite go out far enough. Nope. So that only goes to Sunday evening, but you can already start to see this plume of instability starting to organize over the Gulf Stream offshore of South Carolina, and this is going to overspread eastern North Carolina. And as that parent system gains more of a neutral and eventually a negative tilt, it's going to allow this instability axis to hang on during most of the day on Monday across eastern North Carolina, southeastern Virginia, and into the Delmarva there. And we do have the new GFS coming out as well. Here you can see by Monday morning, this is surface-based Cape. That Cape axis starting to move on shore there in eastern North Carolina. And of course, the GFS is a lot more meager in terms of the development of instability across eastern North Carolina. And this is the new GFS too. So if you're a severe weather lover in eastern North Carolina, then you definitely want to side with the NAM model. The GFS is showing quite a bit less in terms of instability. More of a progressive low-level jet axis pushing off to the east. Let's look at some of the differences between the NAM, 12Z NAM, and the GFS. So see how the NAM holds that low-level jet across the mid-Atlantic. It keeps it on shore across eastern North Carolina, eastern Virginia. It's a lot less progressive with that upper system. Here's the NAM upper pattern showing the trough of the, showing the main axis of this parent trough back over the Great Lakes. And the GFS has a bit more progressive of a northern stream system with that axis a little bit further south, a little bit further east in the NAM. The GFS definitely causes the southern stream system to really lose its identity a lot faster than the NAM, whereas the NAM kind of retains that upper level system much longer through the day on Monday, holding that low-level jet over eastern North Carolina and eastern Virginia. So that's the difference. I tend to believe the NAM because I think this bowling ball of an upper-level storm system, that cold air aloft, I believe it's going to retain its identity a little bit longer than the GFS is showing and help to boost that elevated mix layer coming in here to eastern North Carolina and eastern Virginia. And that's going to lead to breaks in the clouds and the development of that Cape axis to form. By Monday afternoon, though, this parent system centered over the Great Lakes. There's the upper level storm system. Let's see exactly where the surface low is on the NAM. Parent surface low here in central Pennsylvania. And the models have definitely trended east with this surface low late last week. Many of the models were showing a surface low moving through Ohio, closer to the Ohio-Pennsylvania border. That would have brought the main swath of snow right through Ohio into southern Ontario. The GFS even was showing 15 to 20 inches of snow across Cleveland. But this further east track here is going to be less snow because that deformation zone is going to have less cold air to work with out here. So you can kind of see a little more diffuse of a swath of snow with this further east track. The exception being the lake enhanced zones here of northeastern Colorado, northwestern Pennsylvania, the higher terrain of western New York. It's really going to be more of a terrain-focused lake effect event. That terrain just inland from the waterfront there in Erie. It's probably going to get a lot of snow, but then right along the waterfront where you get some moderation of those low-level temperatures from very warm Lake Erie, that's going to cause that snow to mix with and maybe even change over to rain at times there right along the coast. That's going to hold down some of those accumulations. Looks like this is going to be a big event for Ontario, though. And then as the system lifts by, you'll get that lake effect snow machine reinvigorating off Lake Huron and Georgian Bay. Here's the lake effect beginning. And this is going to be Monday night into Tuesday still when you have this lake effect dominating southern Ontario. Big lake effect event, prolonged lake effect happening there in Cleveland. Detroit, according to the NAM, you're probably going to get in on the action here, and we're going to look at some of these snow maps to see what the different scenarios are. So here is the latest NAM snow map. It's definitely picking up on the snow belts and the lake enhancement there. But look at that. It looks like Cleveland's going to be the winner, according to the NAM, with potentially up to 1.5 feet through Tuesday happening there. Then you can see the snow squall totals in the spine of the Appalachians. Several inches of snow down here in the Smokies. The southern Appalachians near the Tennessee, North Carolina border. Even the NAM is showing 5 to 8 inches of snow up there. So even if this tornado threat does not materialize in eastern North Carolina, I'll be covering these snow squalls in the higher terrain of the Appalachians. I'm thinking about summiting Grandfather Mountain up there in the Appalachians. Experience some of the wind and whiteout conditions up there, Grandfather Mountain. Maybe Mount Mitchell. And the NAM is definitely still showing a 6 to 10 inch type snowfall for Erie, even right along that waterfront. But I think the heaviest snowfall totals are going to be just inland a little bit from the lake over the higher terrain of northwestern Pennsylvania. Western New York's definitely going to get in on the action. And that Chautauqua Plateau out there, the higher terrain across western New York. And the NAM even has a good 5 to 8 inches falling here across the Thumb and the Detroit area of Michigan. Decent snowfall across Ohio too. Cincinnati could get 5 to 6 inches according to the NAM. But the GFS still has a different evolution with that upper system. But the GFS is still showing 6 to 10 inches of snow in the higher terrain. Smoky Mountains up there, straddling the border between Tennessee and North Carolina. And it also has Cleveland getting hammered still from this lake enhanced event. And you're definitely going to require the lake enhancement to get some really big snowfall totals. Detroit, probably a 2 to 4, 3 to 6 inch type of a snowfall up there. And let's see what last night's Euro says. And this is on the pivotalweather.com website. Incredible website for model visualizations. I see that they do have some new imagery on here too. Some holiday sales for the Pivotal Weather Plus package. And it sure looks like heavy snow, significant snowfall for the southern Appalachians, for that area straddling North Carolina and Tennessee. Heavy snow there is almost a certainty, and that includes areas probably just in the higher terrain just outside of Gatlinburg. Gatlinburg could see a dusting of snow out there, but really Smoky Mountain National Park, Mount Mitchell, Grandfather Mountain, going to get hammered. The GFS has quite a bit of deformation band snow somewhere across this is the European, somewhere across northwestern Ohio. The European does a much worse of a job at resolving the impacts from lake enhancement, the exception being up here. But the European has a decent swath of snow through Ohio, maybe Detroit, potentially getting more snowfall, more of a 3 to 6 inch type snowfall from the GFS. So really tomorrow the live briefing is going to shed a lot more light on the eastern North Carolina setup. But right now the NAM is showing pretty substantial severe weather across eastern North Carolina, whereas the GFS is showing much less in the way of severe weather. Look at this initial pop in the low-level jet, a little lead disturbance here. I thought this was actually the cutoff system, but it looks like the main cutoff system is behind it, and this is some type of a lobe, maybe some right entrance region of this jet streak lifting through the mid-Atlantic ahead of this cutoff system, causes this low-level jet pop, kind of the right entrance region of that jet, looking at 300 millibars. So it's definitely this preceding jet streak here ahead of that cutoff system, some type of a subtropical connection with this low-level jet that lifts it off into the New York City area, and then in its wake, the arrival of that elevated mix layer with these southwesterly winds and this low-level jet pop. This is 15Z on Monday. It's a 60-knot low-level jet there in eastern North Carolina. And the elevated mix layer hasn't arrived this far east yet, but it does catch up, overspreads the area, boosts those lapse rates, jumps the temperatures up into the 70s, and we retain this hodograph shape here, characterized by strong low-level flow, kind of a shallow critical angle, but critical angles of about 45 degrees are pretty common here for severe weather events east of the Appalachians. We're going to be watching this closely, likely to activate storm chasing mode on some front, whether we chase both the tornadoes in eastern North Carolina and the snow event at the ridge line there of the southern Appalachians, or one or the other, depending on if you like the GFS, the NAM, or the European model. I tend to be more of a NAM oriented person. So thank you everybody for joining me. Hope you guys enjoyed this weather report. We're going to keep a close eye on this tornado threat in eastern North Carolina Monday. Winter weather alerts too for the Appalachians all the way up into southern Ontario. And then that secondary barrel, the kicker system coming in, that's going to reinforce this eastern U.S. cold through early to middle part of December, kind of going back to that ridge trough pattern that we became so used to over the winter during recent years. So thank you, everybody. A lot of exciting weather ahead. Hope you have a great rest of your Saturday. My mom and I are going to be going on a nature hike today. We'll share more of those beautiful scenes of nature on this last nice day in the southeastern U.S. before a major pattern shift is going to bring an Arctic blast to the eastern U.S.